Hello, welcome to AUTOMAT Live-Coding. Today we are continuing the assembler project. Let's zoom in at the big picture, so maybe zoom out at the big picture. So we are in the second half of the project. I think we started in the second week of January, so I'd say we are doing quite well. The instruction factory widget, or instruction library as we call it, is almost complete. It's not perfect. It could have a slightly better way of selecting input and output registers, but the table that we made, I guess it works, so replacing this is more... it's probably worth switching to a better way of selecting registers. Let me show you. But really, it's not a priority. So this table here, right? I think this is, first of all, it doesn't cover all of the possible instructions. Because, for instance, if I would like to have an instruction that makes XOR, for example, okay, I can do it. Okay, so for some instructions work, but I think if an instruction has like three register arguments and they all can be different, I think then our table-based approach, it cannot express all possible arguments. And it's also not super obvious how it works, that it's a filter. And that those numbers here, they show you how many cards will be in the deck once you filter. The goal here was to show a tiny banderole, like something that you put on a deck of cards to, like a, I don't know what's the name, something that indicates that it wasn't opened. And on top of it, we could write some number. I think if we use this style consistently here and here and here on this deck, I think then it would be very clear that this is number of cards in the deck. But as it stands now, it's not. It's not ideal. But it works, so we are moving ahead. Today, the plan is to actually do 5 different things. We are ambitious, as usual. I think if we get 4 of them, I'm going to be happy. So first of all, the instruction library doesn't allow us to pull instructions out of the library. So it's a fairly important feature. It's like the critical feature. It's not kind of complete until we can actually select instructions using this library. So yeah, we have to fix that. Then I want to finish describing all of the instructions so that we have instruction cards for all of them, like including those, and those control ones, and those miscellaneous, and those, and those, and those. I started feeling move if, but I had some issues here. I guess it works now. Anyway, I was trying this on a Windows machine this morning and I was having crashes. This is a little bit concerning. Anyway. So, okay, I will actually start with this the stuff that's missing here. So some instructions, they can have conditions attached. The x86 architecture contains 16 conditions, like the base instruction set. And those conditions can be put next to some instructions. There are just a couple instructions that support them, very, very few. And they are actually very popular among low-level programmers because they allow us to write programs which avoid conditional branches. Fun capability. It makes the programs a little bit faster, it makes them harder to analyze, it makes them slightly more resilient against some attacks, like side channel attacks. This is for security people. There are a couple of those instructions. We have setIf, we have jumpIf, and we have this moveIf. Maybe instead of move, we should call this set. Or I don't know. Or copy. Because moving, I think moving is in our metaphor, and we are going with those squads of units holding flags. Moving would be about actually moving something, like taking a pattern of flags and from one place and moving it elsewhere. So I think a better name would be to copy or to set, something like that, which doesn't imply destroying the original value. And we could use simpler terminology. For example, instead of exchange, we should say swap. Let's do it. Let's do it now, right away. Okay, so we have exchange here. It's now called swap. We have no more exchanges here, but there is a Python file, right? It has this category, and we will call it swap instead. So now when I rebuild AUTOMAT, we should see this. The order of arguments doesn't really matter here. Okay. So I wanted to draw the condition codes. Oh, I know why it's not failing. Because of this. I commented out the problematic code. So now when I try to show those cards, yeah, it crashes. Nice, nice. I'm going to run this in debug mode because when it crashes, this allows me to inspect what is actually happening with this operand. Why is this get immediate failing? Okay. We are in this get immediate. Okay, so apparently this operand believes that it is a register. Very, very strange. cmove not equal array x. Okay, this is interesting. It has 4 operands.
Knight says,
Hey everyone.
Hey, Knight. I remember you've been asking some months ago about videos from Causal Islands, Berlin. They are slowly coming out.
Ravensima just followed on Twitch.
Hey, thanks for the follow. They are coming out slowly, but they should come, I guess, this week. This channel here.
Great. Topped.
It took quite some time, but you know, people are busy. Everybody's kind of captured by their stuff. Okay, that strange thing, why is this? Let me see if I can actually use console to inspect those values, because this navigator, it has some issues with analyzing MC operand. It has 4 operands. Operand 0 is a register, value 51. Let's actually check this out. Okay, this is array x. Operand 1 is also array x. Operand 2 is also array x. And operand 3 is the immediate. Okay. So strange. Okay, I think I know what's the thing. This is the LLVM thing where it likes to duplicate output registers. So the first register is actually specified twice in the argument list. This is common. Okay, we can fix this. We can just switch this to 3. And this we should switch to 2.
I just checked. The part where you had your conversation hasn't been published yet.
Yeah, it will probably be coming over this week. They just started to edit them right now. Okay, so here we should show the condition. And I wanted to check something out. Let me grab a font. Can I see? Okay, I can't really see individual characters. I'm looking at how the shape is constructed, because I want to have something similar here on this display. I see that the right edge is slanted, but the left edge is cut straight. That looks nice. So, for all the conditions will have similar shapes. Let's design one. I actually wonder, how do we align those glyphs? Maybe they should be centered. Yeah. This is a fairly low angle. Okay. This is our rudimentary copy of that glyph. Okay, now it's fairly symmetric. I mean, the boundaries are symmetric. I think here we could draw it in a slightly nicer way. Okay, let's grab this. I will grab all of those condition codes. And the star that we've just drawn here, this is below equal, yeah. So this is a variable which is, I want to have something pre-computed in like global memory so that we don't have to recompute this path all the time. I think Skia actually uses reference counting to track paths, so this should be very cheap. Actually find path internals probably around the end. I think I've seen them, yeah. Here, there is a path reference. So this copy is cheap. If we go with the blackboard style symbol, it should be white. And we'll just draw it like that. Or maybe not quite like that. I think we should center it. So we should move to the center. And draw, then move back. And I will call this compute tight bounds because, yeah, we can do this once. Why Why shouldn't we? I generally think this could be actually is this path from SVG. Okay, we don't really need to do that. We can just call path from SVG. So there is this condition for signed integers, which I think is, it could reuse the same symbol. Let's put it here. The same with less. Greater equal. And greater. Now we have to remove those things. We are left with greater. So this is sign. Okay. This parity condition in x86, it's kind of strange. It can be used to check the parity. It doesn't just check the last bit. It's actually more complex than that. Anyway, we are interested also in those equal, not equal. Because this overflow No overflow. We don't care about them right now. Let's do equal and not equal. I think the size should be kind of similar. Here. I don't know. We'll see how it looks. Okay, short break. Be right back. Not equal is going to be slightly harder. Let's see what variants of not equal does iOS has. This equality actually has very short spacing between the lines, slightly different than ours. Definitely not this. and not this. So something like that, but with thicker lines and closer.
Game Train Studio says riding with 7 viewers.
Oh, hey guys. Okay, I guess I can kind of mention what we are doing here. So we are trying to program an environment for doing macros, something like AutoHotkey, if you're familiar with that. This is just for recording sequences of keystrokes that can be then repeated. This can be used in like all over the place, in desktop in general, but also in games. We are actually thinking about using this in games, specifically to automatically grind levels in... There are games like that where you just have to do it.
Game Train Studio says.
There we go.
Yeah. So, AutoHotkey, you may be familiar with this because this AutoHotkey, this is the state of the art. This is how most people approach automation, and also how I approach automation when I have to do it.
Froster says.
Hello.
So in this environment, you basically write a script. You kind of need to be familiar with some kind of programming language to access clipboard, to send events to the program. So it's not super really accessible to all of the people who use computers. So here we are trying to address this by wrapping this in a more convenient interface. We have those objects, they can react to hotkeys. When I activate this object, you can see that when I press F3, it blinks. And there is also like a short pop. I can hook it up to this object, and there are some visual glitches here, but you can see that it switches it on and off. Or I can hook it up to just other stuff on screen, and we can... So this object here, it's actually slightly different because it manages other objects around it. So specifically this macro recorder takes care of the macro recording process. It creates a timeline, and when we record the macro, I can, for example, place myself here, press F3, come on, stop. Okay, it doesn't want to stop recording. Well, yeah, we have some bugs. But anyway, the idea is that we have this object which records the macro for us, so we don't have to create those objects manually, we don't have to hook them up manually. And when I play it back, it will send those keystrokes. They don't do anything because arrow keys are not interpreted in any way. Yeah, but you can see that they are actually pressed. Yeah. Anyway, so this is, say, the core of AUTOMAT. And now we are trying to add some way to control it a little bit better. So, for example, to create loops, to create conditions, this kind of stuff, to steer the flow of execution. And we will do this using those cards. Those cards, they allow us to describe some basic operations and then compose them. So if you want to have a loop, you will set, for example, this is a register. This is something that can store a value. So a group of units will hold a value, for example, I don't know, 10. And then we will have other instructions, for example, to lower this value by 1 and to jump. For example, to do conditional jumps. There are some very interesting things here, because those cars, they actually map directly to x86 instructions. We can actually execute this straight on the CPU without any sort of interpretation. So it's incredibly fast to execute. I mean, it's not like we need to be fast, but it's just a nice thing to have. So it's an environment for playing games, where we can also access the high performance of the CPU. And it takes quite a bit of time to set everything up. Right now we are trying to draw the conditions on the cards properly. So it may have some resemblance to Balatro. This resemblance is not accidental. It's like I was playing Balatro literally early January, so it may have influenced me a little bit. Yep. So here is how we design graphics in this system. We basically manually design the SVG shape in this editor, and then we copy paste it over here so that we can effectively, efficiently draw it. Okay, I didn't mess anything up, I hope. Okay, I want to add another shape here. Maybe like that. Something is not right here. Let's make this relative and this move to... Oh no, it's not symmetric. I need to use fractional positions to make this symmetric. Now it should be good. Okay, so this is our symbol for not equal. And let's see how this looks. Nice. Hey, actually, it's better than I expected. The size is correct, which is most surprising. Okay, we have no way of changing this condition yet. Okay, it's a very simple SVG shape. I'm wondering maybe we could cut those horizontal lines.
You look like Yamai from Infinite Wealth.
I'm going to check this. Okay, yeah, I see this. What is Infinite Wealth, by the way? RPG.
What's up, everyone?
Sorry for that. Okay, this game looks nice.
It's my favorite game.
Yes, when I saw this short video, it feels a little bit like GTA, but slightly more absurd and with in a completely different setting. It looks like it's open world, and this is what I like in games the most. Like, I really like when a game kind of gives you this sandbox where you can run around and do whatever you want. Should be thicker, like 0.4 millimeters. Cool. This is a total accident that the equality sign seems to fit so well into this box.
You also look like Uncle from Another World, but cooler.
Okay, let's cover more instructions. So one of the things that we want to do today, we have 5 things to do. So this condition code token, I think we've implemented actually. It's decent. We haven't covered all of the conditions, but this is not a priority for now. Now we can describe the remaining instructions, do the machine code, because in the corner of the card, in the bottom right corner here, there should be some hexadecimal codes that will match this instruction, and register size. So below each register we should print the number of bits that this instruction will set, because this is often like the main difference between a lot of those instructions. Like this is the 16-bit, this is 32-bit instruction, this is 64. Anyway. So now that we have condition codes, maybe let's do the all of the conditional, control instructions. Okay, I have no idea what's the deal with those rev instructions. And my trick for doing this is to just select this whole block and call language model to do it for me.
Madakimk says,
Sup, math how?
Hey. We're at this nice stage where half of the time we're actually waiting for the language model to finish the work for us. It's like thinking right now.
Is this LM?
I mean, it's not this. The language model is writing the code for us right now. Okay, those compare and exchange instructions, I should get rid of them, because this... Okay, and JCC2 as well. And JCC1 probably also. So compare and exchange, it really only matters if you're writing multi-threaded code. And our subset of assembly doesn't use multiple threads. We are only operating on registers. The cores cannot communicate. So there is absolutely no reason to have those instructions even on the list. They will be just confusing. So let's apply whatever the language model proposed. Okay, I don't like those changes. Sorry, what is happening here? Okay, so it did implement some stuff, but it also messed up a lot of other stuff. Yeah, language models often do this. I think I'm looking at the damage that it has done, and it doesn't seem to be significant. I think we can go ahead and accept this, because in the end it did implement a bunch of instructions.
I was about to write my own SQL table generator and row selection with G, but then I realized there is default ear diagram in the MySQL. FCKG.
You mean MySQL creates some diagrams for you? I had no idea this is a thing. Oh wow, it really messes up things. Can I just close this? I don't want to commit. Okay, so this is the downside of working with LLMs. Sometimes they will just totally break your code.
Yeah, I mean there is D, where you can design graphic.
Haha.
LM the
What?
Killer XD.
Yeah. MySQL Workbench. I'm not familiar with that. I'm looking at the menu. Some of the things are immediately obvious to me, like those arrows, but those things, not quite. I mean, it's probably super intuitive. Speaking of LLMs, graphs. So there is like another category of transformers. They are generally called graphical neural networks. And this is because if you have a graph of objects, like edges joining vertices, you can also run this on a transformer, and the transformer can...
So I was about to do the same, but with auto-generated by using commands, such as show databases, etc.
So this modality of things on a canvas which are connected by arrows, this is also something that transformers can work with. You literally have, I think this is the best picture here.
What is transformer? I am sorry.
So this is the matrix multiplication step within the language models. This is a mechanism that allows neural networks to direct attention to specific parts in the text.
Like Optimus Prime? XD.
Yeah, they are not super transformative, but yeah. So this solved like a big problem in language modeling, but in graphs, this problem is also there. And ironically, even though they are they seem to fit naturally in graphs, they are very computationally expensive, so they mostly work with relatively small graphs, up to a couple thousand vertices.
Looks hard.
Yeah, possibly. It's about, I think a lot of this is about kind of just playing with this. It's really no different than databases. Yeah, if I would actually grade like the complexity, I think neural networks are about like the same level as databases. So most of the people who are not into databases, they don't know what is normalization. They don't know what are relations between databases, between tables, columns, rows, like fairly obvious things to anybody who works with databases. Same goes for neural networks. And I'm actually not sure which would be harder. Honestly, maybe databases are harder than neural networks, because especially the distributed ones, the complex ones.
Well, DB is kind of default programming knowledge, am I right?
Yeah. Because it's taught at like pretty much all universities. If you like want to be like certified as a programmer, you kind of have to go through this. Okay. I'm going to click this button because Cursor, the environment that I'm using, is just so broken that it messed up my code, and the only way to fix it is to actually accept the broken state. Like, this reject is not going to do anything. I have to do this accept, and then maybe I will be able to fix it. I don't need those.
BW, what's your far-right way to use DB? Like inbuilt Java methods, hibernate, etc.
I always liked ORMs. I think they're decent. When you're dealing with SQLite, I think it's I haven't seen any ORMs for SQLite. For SQLite, it's always like just writing queries manually as strings. Yeah, but I like to kind of defer this database mapping to this special library that will make this work for me. I think it's similar to Java Hibernate. I haven't worked with this, but I don't have any personal experience there.
I've heard about Orange Light. Is this good?
I don't have any experience with this, so I cannot really say.
We're now using Spring Boot to interact with DB, and I don't know if it's overkill in a project which not using all the Spring Boot features.
It really depends. Honestly, even though I'm totally not in this ecosystem, I heard this name many times, so I think this Spring Boot is a fairly popular, standardized technology, so it's probably not going to be a surprise to anyone. I have to see this being used.
So I want to find a solution for interactions with DB only using libs, not frameworks.
You know, there is this standard approach of connecting to the DB and sending SQLite requests. SQL requests. SQLite is embedded in my subconscious, so when I say SQL, Lite follows. Just database connection. When you have a database, you can just connect over TCP to some port and just talk with it.
Well, Spring Boot using Hibernate, so I guess Hibernate. Is that what I'm looking for?
Yep.
We're RB in a 15 mins.
Okay, here I am actually very disappointed by the language model. It used to generate perfect code until now. And now it messed everything. Okay, this is good, but I think this is what we wrote. Okay. I hope now it's going to be correct. Maybe there are some mistakes, so I'm surprised to not see the 16-bit or 64-bit variant here. Okay. Something is messed up. I think this should be 2. Still not it. We are using 2 large indices somewhere. It could be here. This is not a register. I am going to comment out all of the register operands. Now it should run. Oh yeah, I see. This was misplaced. Exactly, so this is what I just mentioned. I was surprised to see a missing variant here. And here. Here are things that we still want to cover. Let's get rid of those compare. Okay, they are gone. Now let's get rid of this 2-byte jump. So we have jumps. Oh yeah, so we have conditional jumps. Here we forgot to get rid of the 2-byte one. A lot of test instructions. I will commit this, and now I can safely ask the LLM to do work for me. Let's, for example, grab those. So I'm expecting the model to create 3 groups of instructions. One, which uses the IX register. That's the 16I16, 32I32, 64I32. Then another group, okay, it didn't pass. It actually messed it up, but we can fix it. Okay, I think that should be it. I have no idea what is test UI, test user interrupt. Yep. Okay, we can skip this. This is related to interrupts. So we have this, we have all of the comparisons. We have the jumps. I guess now conditional jumps. I have no idea what those instructions even do. Like JRCX0 jump if RCX is 0, but why it's different than ECX? Sorry. Hey. It's not particularly fast. So the larger the file, the more likely the model is to mess up something. Yeah, like here. I mean, it didn't completely mess this up, but it didn't use the proper serialization. We have better tokens for this. think this description focuses on the 32-bit x86, which we don't care much about. But yeah, we have those ECX, RCX instructions that we can include here. Let's do apply. To just accept everything, and now I can actually fix it all. It would be nice if it stopped removing my comments. Okay, so those two jumps, we can unify them. I think I am actually not sure. I think the first argument is actually the address of the jump. And I prefer this format where I say if condition, then jump. Yeah. Okay, loop instruction. Loop equal decrements RCX if RCX is 0 and so if okay, I need to add a new type of conditions. Fixed condition. But first I will copy it over here. And do that. Okay. Cool. So we had tests, okay, we had compares, and jumps. If not equals 0, then jump, okay. So we have two instructions here because they have different jump distances. One of them is 4 byte and one of them is 1 byte. If circles equals 0, then jump. Okay. Okay. This is our loop instruction, which decrements the CX register, and if it's 0, then jumps somewhere. And this is the instruction which checks the flag value for equality. Also fine. Nice. Those jumps we had already. So all of the instructions which have the relative, like PCRel argument, there is this type of argument. It's probably not an operand, but for those we will have a plug on the right or on the bottom. Then we have setIf, we didn't implement this one. And then we have conditional sets. Okay, so let's do this set CCR.
Knight says,
Is VS Code the ID you are using?
Yep. I am trying to switch to Z, but it's still missing some nice functions like the explosions. Z doesn't have explosions, and unfortunately it doesn't have the backgrounds. Yeah, so those are things which are very unlikely to happen in the near future, because those things are not commonly kind of asked for by programmers. But I also like Z because Z is fast. And yeah, I do have issues with VS Code just being incredibly slow to work with, especially on Windows. On Linux I don't feel this as much.
How did you integrate the AI that you just used?
Oh, so there is a version of VS Code called Cursor. So they have some extra functions, like when I select a piece of code, I can press a shortcut like Ctrl-L and ask the AI to do something. Depending on the model, it can do better or worse job. Cursor is a subscription service, so I have to highlight this. I think they may have some free kind of period, I'm not sure. Actually, Z also has this. Z also has AI integration. You see on the front page they say this is the editor for like AI. Actually, when Z was kind of conceived, nobody was even talking about this, so they kind of pivoted towards AI. The whole point of Z was that it's just a very fast editor implemented in Rust, I think. So it has slightly more efficient stack, less moving pieces. Do I like the JavaScript part of VS Code? Could be done better, but I like having the editor configurable in some kind of programming language. It's like Emacs. So in Emacs I can have my own script which kind of runs when I start the editor, and it can configure whatever I want. And VS Code is very much like that. It feels like Emacs, almost. Like a modern version of Emacs.
Looks very nice. Let me take a look, because I don't like Copilot in the current version of VS Code.
Marek Kowalski says,
Hi, Marek. It's slow because it's Electron-based. I have the same feeling about Z. It's not ready yet, but it's very promising.
Yeah. So one thing I would like Z to do, and it's impossible, they will not do this, would be to have a scripting engine that could be used to write extensions. They say they have extensions, but those are just formatting rules and templates, or themes. So it can look slightly differently. Syntax highlighting and themes. That's basically it. The only two types of extension that it supports. It looks like there are like tons of extensions, right? But all of them are just two types. If Z had some scripting language, honestly, I would just add those missing features like backgrounds and explosions and... Okay, maybe not this, maybe not chat, but the cosmetic things. Totally. I just added one last instruction, which is set to 1. Yeah. So by configuring this, we can select different register. So this instruction allows us to copy flag into a general purpose register, into the lowest bit specifically.
Madakimp says,
In back, trotting.
I think those are all the control instructions. We covered everything. Cool. Next are flags.
Music slaps harks.wall hard.
Yeah, it took some time to generate this kind of music. Music is, of course, automatically generated here.
WTF, that's cool.
Okay, how much do we have left? We also have those miscellaneous instructions. Not a lot of them. 1 core, a couple CRC, some random instructions, some time. I think one of those is actually only for the kernel, so I think we can only use only this one. I'm not sure. And then we have, yeah, all of the math instructions, which we still didn't. Yeah, I guess some of them we have.
I like Bigger Bite from album My Dear Enemy. It's kinda cool that this banger were generated by AI.
Yeah. AI music, it gets kind of repetitive. I don't think it's comparable to like average like human music. It often doesn't try to tell any story. It just loops some kind of theme over and over. Like actual music is usually it like has some more like content, like something that actually some more artistic value. I don't know how to call this. I just don't feel this in AI music. It's nice, it's good for filler, and it doesn't have any copyright issues, so I like that. If I could, I would totally play different music. Yeah, tons of cool stuff, but I cannot play this on stream because copyright.
Gucci gang, Gucci gang. Gucci gang, Gucci gang.
looks like this 64-bit version could be there, could not be there. I think we can skip those instructions. I think there are better ways to load flags, more clear. I will get rid of this category. I will put this in this specialized stuff. Okay, this STI and CLI, also I will move this out. It will be just super confusing to see those instructions. Which cannot be used in any way. Maybe not super confusing, but a little bit confusing. And the same goes for direction flag. I don't think we have any instructions that use direction, so... So now that I got rid of the direction flag, okay, actually there are just 3 flag instructions apparently. It's weird, so few. If there are so few, then maybe we can merge this with other category.
Quircaptero says,
Sig6 instruction cards, huh?
Yep. This is a big bet. I'm not sure if this is going to work. And there is a lot of those instructions. We are just scratching the surface. For fun, I computed the coverage. And it was something like, with like a couple % of all instructions. Okay, I am removing this category completely. So this Python script is responsible for taking all the x86 instructions and grouping them into categories, which we can then, from C++, display. So we have a new category just for the carry flags. This setIf. I think this could be joined with this moveIf. Because they are kind of similar, especially, I mean, we don't have any constants, but it's like almost the same thing. So moveIf and setIf, so let's merge them. Okay. So we have a lot of compare instructions, a lot of test instructions, but we have just 2 jumps. So maybe we could merge those. How many do we have? Here. 8. That would make it 10. Yeah, let's do this merge. I want to reduce the number of leaves because it's kind of busy in this section. Okay, now it's better. The leaves don't overlap and they are actually shorter. and we have regular jumps. I think we may remove the 1 byte jumps. Yeah.
Missed your streams.
Nice to hear. I mean, in some way it's nice to hear. Okay, core ID CRC32. I wonder. I think it would be good to avoid those for now. I would like to have those instructions, obviously, because they are simple and they are there. We just could support them. But I think they will be a little bit... I'm still looking for the good word. I keep saying this is scary, but what I mean is something slightly different. It's not... Nobody's afraid of this, but... What I mean is that some terms, some UI design patterns, some things that you can now see, they have technical connotations that tell some people that it's not for you. And I want to avoid this. I want to avoid this. It's not for you. Subconscious signaling.
Since when you and Max touch?
Actually, I have no idea why I started using Emacs. That was a long time ago.
Spooky language.
Yeah, spooky language is good. I mean the term for this thing. Let me check some translation.
And do the George Carlin bit. He said it about religion.
I think I've seen this. Yeah, he's amazing. Startling. Startling is another word. Yeah, I think this is the... It's not perfect, right? Language is not perfect, but this is probably the best description of what I think, what I mean here by avoiding technical terms. They are startling. Okay, RDTSC and RDTSCP, what's the difference between them?
Yee, alien language.
Or alien, yeah. Yeah, I think Alien is probably better. Okay, RDTSC, read timestamp counter into EDX, EAX, and the RDTSCP.
Medarkimp says,
Yo bro, I just found free API for geometrical core.
Like for CAD applications. I heard this name, I think, in the context of computer-assisted design. So it's like a geometry library, I think.
Pepepzero says,
Or what?
Medarkimp says,
Yeah, and it seems not hard, just boring.
What's the library?
Oh, it's Nexerpi. Inks, it's like CAD Flagman. I didn't know it has an API like this.
It's not it.
It's not exactly direct to geometrical core. It's just Enk's API with using geometrical core.
URL.
So that way I'm able to try my things on geometrical core. WTF? It has country block?
I'm not sure. I think this could be just internet issues. Is it NX or NH?
Pepepzero says,
Oh, move B2 to up.
Yeah, I didn't understand most of this, only that there is this NX. Is this related to this NX? I have no idea what this is.
Medarkimp says,
Next, not NH. You can try Unigraphics and Xbox. It's not looking like Angst-Pied.
Huacaptaro says,
Initial release 1973.
This is how you know it's good software, right? It's the survivorship bias. If it was released like 50 years ago and people still talk about this,
Madarkimk says,
IDK, why but it shows only for me.
Huacaptaro says,
Amex is cooler, Dwight. More new.
cool stuff. So is this library actually storing all of the objects as like mathematical shapes, or does it have like a common denominator? For example, NURBS surfaces, because I know like voxels or this kind of stuff.
Fidget gotta write it up a project.ru.
URL. Madarkimk says,
I don't know, I guess it's just methods that runs into NEX and NX retranslated into geometrical function.
Huacaptaro says,
It's an implicit surface CAD. Kernel Python. Better look at right-up page.
I always thought that this is still largely an open problem, like manipulating those mathematically defined shapes.
It's more constrained than shader toy. Really just trees of simple math ops. Low cost effect. Mass Effect.
I wonder how the rendering happens. So for each pixel we have to evaluate some function. I just wonder, or maybe not. Or maybe we have just a bitmap and for each shape we are like drawing something on screen. Okay, so it's compiling this. But this is a three-dimensional function. Okay, that is nice. Oh, this is a clever trick. So instead of evaluating it at a point, you can, compute a range. Okay, I see how this works.
Patrick Drevestet says,
Hey, how's it going today?
Hey. We're slowly progressing on the assembler environment. We have cards for all of the control instructions already. Sample 4, I don't know. Setting register, some miscellaneous. Actually no, these ones we don't have yet. Anyway. Okay, this is actually a very nice way to kind of think about geometry.
QCapet0 says,
It does shorten tapes for different regions.
I haven't yet read about tapes. Oh, you mean this?
Special ISS.
Oh wow, that is actually very impressive. So that in some region, like some value is always greater than, for example, 0, and then you don't have to kind of compute half of the graph. I guess this is how I'm understanding this thing.
Patrick Drevestedt says.
Nice.
Copapero says.
Yee.
Patrick Drevestedt says.
Looks good.
That was a super interesting find. So this is like a completely different way to look at geometry in the memory of the computer. So we can have distance field, which we can like walk along the rays. And we can have those range evaluation for implicitly defined shapes. So cool. I'm thinking how this might work in 2D, in 2 dimensions. Right, because 3D is definitely more complex than 2 dimensions. It would be nice if we could have something like SVG, but where we could have shapes defined like that. That would be like way better than SVG, actually.
QXero says.
I mean, this is SDF. They're used for font rendering.
Really? I always thought that fonts internally, they are just a bunch of Bezier curves. But hey, maybe I was wrong. This is the first time I hear of this representation, actually.
Somewhere, like in Valve games.
I mean, so what is happening here is this is similar to sine the distance function, but it doesn't have this issue that you require like just tons of steps. I mean, you still require many steps probably to kind of draw every pixel, but it feels different because you have this min-max function for every shape.
You have general representation. That can be optimized to run fast on GPU. It can be compiled to CPU.
Yeah.
Without using the SLSL dial. Not yet open research problem.
Cool. Okay, and to convert this to mesh, you have to kind of walk around the shape. But it's nice that it's convertible, actually. Yeah, I think converting from this representation to meshes it's a nice problem, but yeah, just staying in this representation is also nice.
Thanks for checking.
Oh, and there is a demo, a real-time. Okay, let's try this out. Projects Fidget demo. Okay, we cannot do powers. Okay, I think this is for powers. Okay, unfortunately we don't have a lot to play with. Yeah. Incredibly cool project. I love it. I mean, the demo could use some like extra functions, because this is essentially shader toy. Okay, so there is a square function. Okay, so we cannot even square. I mean, we should be able to square right like that, right? If we can.
Actually, I'm back, cause I started implementing your cable algo for my app. So bye.
Yeah, see you around. Okay, I was going to take a look at the time instruction. And I see we have two variants, RDTSC and RDTSCP, where one of them just does a little bit more. It stores this extra register in ED, like CD, ECX, yeah. Okay, so RDTSCP is just LDTSC plus like a core ID. Okay. We will describe them in a second. I will make a short break first. So, there is a video I wanted to watch. It's from a series on user interfaces. And I need to grab some food, so I think this is good time as any to actually watch it. Let me just locate it. Let's grab music. Silence this.
There's a Zen koan that goes, "Who is the great master, the magician that makes the grass green?" You know how
So, maybe strange that we're watching this video, but this is because the author is kind of went on a tangent a couple of videos back. It actually started as some exploration into how desktop affects us, and are there any other approaches to graphical user interfaces. So we are fairly kind of deep in this rabbit hole. I still expect that we will eventually get out, maybe with some extra knowledge. So let's see how this looks.
there's a Zen koan that goes, "Who is the great master, the magician that makes the grass green?" You know how some people have those lawns that are so bright green they're almost fluorescent? Until I was about 6 years old, I thought those particular lawns were orange, because I'm colorblind, and I hadn't yet learned that grass is green. I also thought the Incredible Hulk and the Wicked Witch of the West were just really tan. But one upside to being colorblind is that in early childhood, you understand from lived experience that there is no greenness to the grass without the presence of a great master, a magician. And that master who makes the grass green is you. Green can only happen when the grass meets your nervous system. When it meets my nervous system, something different happens, something unusual. And now when I look at grass, I use context to see it as green. And I use context to see the sky as blue instead of purple. Language has something to do with it as well. Language can change how we perceive color. Sir Isaac Newton demonstrated this when he changed the rainbow.
A double rainbow with all those colors, holy cow.
In 1704, Newton wrote a book called Optics. And in his book, he laid out his experiments using two prisms that prove how the spectrum of colors emerges from white light. And he developed a systematic theory of how the spectrum works. Optics is the first time we see the color wheel, which visualizes this holistic, non-hierarchical relationship between the colors red, orange, yellow, green, blue, indigo, and violet. Roy G. Biv. The thing is, before Sir Isaac Newton came along, there was no universal agreement on how many colors there were in a rainbow. It was fairly common in the West to think in terms of rainbow, which doesn't roll off the tongue in the same way. He took that spectrum of the rainbow and just added further linguistic differentiation between red and yellow to include orange, and between blue and violet to include indigo. And he did this because of an ancient sect of mystics, led by a man named Pythagoras. You know him from his theorem. The Pythagoreans were an esoteric order. They had an elaborate initiation process, so we don't know all the details of what they believed, studied, and practiced. We do know they saw mathematics and geometry as the keys to unlocking the secrets of the universe. They gave us the Pythagorean theorem, they discovered irrational numbers, whatever the hell those are. They were among the earliest Greek thinkers to propose Earth was a sphere and that it wasn't the center of the universe. They have so many hits. A personal favorite being their invention of Western musical theory. The Pythagoreans are why music sounds the way it does today. They discovered that the pitch of a musical note is proportional to the length of the string that produces it. There were stringed instruments in other cultures, but no evidence that anyone ever mathematically broke it down the way the Pythagoreans did. So they realized that if you pluck a length of string, then pluck a string that's 3/4 of the original length, you get a perfect fourth, which is like the first two notes in Here Comes the Bride. And if the second string is 2/3 the length, you get a perfect fifth, like the first two notes in Twinkle Twinkle Little Star. And if the second string is half as long, you get an octave, like the first two notes in brief rainbow side quest here. In the previous video in this series, we introduced the caduceus as the staff of Hermes, and it is, but not exclusively. There was one other member of the Greek pantheon who carried the caduceus. She was the messenger of the gods, and she used a rainbow as her bridge between the divine realm and the mortal realm. This caduceus-carrying rainbow goddess is Iris. The Greeks named the colorful part of the eye after her. Okay, back to the main quest. The Pythagoreans went on to theorize that the sun, moon, and planets move around each other according to equations that correspond to the musical intervals. This idea is called the music of the spheres, and it's totally inaccurate. Planets do not move that way. Like everyone else from 2,000 years ago, they were wrong about a couple things. But Newton, being both a physicist and an alchemist, deeply appreciated the elegance of this model. If you saw the previous video, you'll remember that there were 7 known planets in his time, and 7 alchemical metals that corresponded to those planets. And since there are 7 notes in the musical scale, he really wanted to define the spectrum in terms of 7 colors. And it was totally his right to do so, because where we draw the lines on the map of the spectrum is arbitrary. You could divide colors up in many different ways, and many cultures do just that. Here's a great video about cultural color differentiation that I'll link to in the description. So since both music and color are phenomena that manifest according to their frequencies, he snapped the rainbow into 7 parts, added the musical notes to the color wheel, and published Optics. And a few years later, we got Lucky Charms and Rainbow Road, the most diabolical track in Super Mario Kart. When you study nature, certain patterns emerge, and mystics like Newton and the Pythagoreans see these patterns as hints from the universe that reveal its fundamental nature. And they use these patterns as guideposts for how we should structure our thought in order to be more in alignment with universal truth, which they would call divinity. So when we draw out a depiction of a conceptual system, we need to be thoughtful about how that depiction might shape our mental map of that system. Remember, we shape our tools, and thereafter, our tools shape us. If we're diagramming something holistic in order to create an affordance for understanding, the ideal diagram would avoid any indications of hierarchy, because a hierarchical diagram could subtly, subconsciously skew our understanding and enforce hierarchy where it doesn't exist. Systems of thought that center around holistic relationships and cycles tend to lean heavily on circular imagery. The Tibetan Wheel of Life, the Wiccan Wheel of the Year, the alchemical Ouroboros, the Zodiac Wheel, the Medicine Wheel of Indigenous Americans, Hindu and Buddhist mandalas, not a rectangle in sight. And there aren't many rectangles in nature either. Crystals and honeycombs aside, nature is much more likely to create a circle than a polygon. One limitation of our current information tools is they can't help but impose hierarchy through their visual design. Certain types of thinking, organization, and exploration don't fit into horizontal or vertical formats without a loss of conceptual fidelity. I'm not saying we need to have circular paper or circular monitors, those things aren't practical, but I think it's very important to recognize the limitations of our tools. Before we were constantly boxed in by rectangles, our mental maps of holistic systems were more aligned with the reality of lived experience. And who knows, maybe our creativity was enhanced by this sort of axial freedom. And when it comes to nature and hierarchy, there are different lenses through which we can look toward nature as a guidepost. We can look at hierarchy as an inevitability because we see hierarchies in the animal kingdom. Ant colonies, beehives, pack animals, groups of primates. But there are plenty of non-hierarchical examples, including the largest organisms on the planet by far, mycelial networks. Those are entirely distributed. If you zoom in closely enough, you'll see cells fighting one another and competing. And if you zoom out wide enough, you'll see the entire ecosystem of the planet as a distributed network of equally interdependent systems. So the question is, where does humanity lie on this zooming scale? Are we small? Should we mimic the ant colony? Or are we bigger than that? Should we mimic the planetary system at large and operate as a distributed network? And that question drives the difference in opinion about what code to use for the operating systems of the various institutions within human civilization. But since we started this series questioning the status quo of computer operating systems, I think it's time to tie things back to that central question. How do we want our tools to shape us? What patterns do we want to emulate in order to draw ourselves closer to our ideal state? We are utterly steeped in the affordances designed by others. Why did they design them in that way? What were they thinking about? Were they thinking deeply at all? Or is the design we live with today just the best they could do under a deadline? Were they just trying to survive as a copy machine company in the digital age? How does that relate to our goals, to our vision? Our conceptual maps are filled with lines drawn by others. Why did they draw them there? Is there something important about the nature of reality that expresses itself through the number 7? Or did the alchemists just like 7 because that was the number of planets they were aware of? Would Newton have sketched out Roy G. Biv if the Pythagoreans hadn't been utterly wrong about the ratios of planetary orbits? We can't constantly be redesigning everything from scratch when we learn new information. We have to triage and prioritize. There are things that are good enough for now. They're not doing any harm, they're not holding us back. The cursor on your computer screen tilts at that left angle because of the extremely limited resolution of early monitors. It's still at that angle, but who cares? There are many things that we can wait indefinitely to fix or update. But I argue that the desktop interface for computer operating systems is due for a paradigm shift. And what should be the universal principles that underwrite a new paradigm? And are there sub-principles that should apply to specific users or use cases? How do we want to think when we use our machines? How do we want to feel? The final video will take some extra time to put together, but I hope to see you there in the not too distant future. Until then, remember that you are the master, you are the great magician, you are the one who makes the grass green. Well, at least green for you.
Cool video. I think it touched so many topics and it was a little bit weird to me, like not this video, but the ones before it, because it was very much, it seemed like it was just like rambling on a tangent, but now it all ties back. So we have this, first there is this mention of color blindness, which I don't think it was really like a key point in this video, but it was probably...
What vid? I'm back.
Yeah, you can check this out or just like scroll back in the video, in the stream. So the color blindness is... I don't think this is the key to this video. He touched on hierarchy and how people perceive like some things. Colors, for instance, which can be seen as a spectrum, which can be seen as a like unstructured thing.
Discovered that the pitch of a...
And a lot of the stuff, especially in the user interfaces, it imposes some structure, which the designer of the user interface kind of how they perceive the problem. For instance, hierarchical, like dividing stuff into categories. Literally, the stuff that we are doing with instructions right now is we are dividing them into those categories. This is a very suboptimal interface. There was a different design that I was kind of planning here, where instead of a stack of cards and selectors that allow us to filter through this, we could have... I don't think I have this anywhere here. Let's see. But the idea was to have a map. Imagine something like a fantasy map that shows you continents and so on. So there would be some kind of continents here.
A playfield.
With, I don't know, mountains, maybe with sea around. So one idea for instructions that initially I was considering to actually take all of the instructions that LLVM has and apply a clustering algorithm. But not a clustering, embedding. Like, I guess the term for this is embedding. So that for each instruction, we would associate a point in this space. So instructions would be points on this, in this kind of landscape. This representation, what it actually offers is that it avoids hierarchy. The instructions which are similar, they would be closer together. And we have cases like that in AUTOMAT, right? For example,
Yay.
we have like a bunch of instructions that affect the carry flag, right? Rotate carry. But here we also have instructions that directly affect the carry flag, like set it, like lower erase and flip it. So maybe those two groups of instructions, maybe they should be together. In this interface, they are as far as possible as they can be. So it may make it harder for the user to create this connection. So a geometrical approach, which actually shows this connectedness, like using many dimensions, would maybe be better. This, however, would be a very challenging interface. It would require a lot of design and a lot of experimentation before we would nail it. It's not completely exclusive with what we have in AUTOMAT, so in addition to this, we could also show a map next to it as a different way to view those instructions. But the point of this is that the current interfaces, they impose some kind of perspective on the problem. This is largely hierarchical, like all of the computers are hierarchical in nature. And this is not because people necessarily think about those things as hierarchical, but because of how the screens work. We have limited real estate that we have to use to fit everything. There are laws of interface design like fits law. Or there is one more about like selecting from some number of objects. There are like related laws to Fitts law. Hicks law. And maybe this as well. So because of those things, they are like fundamental things. This is how physical world works. Our brains work faster when they can group stuff into categories. This is what Hicks law says. And we can click stuff faster when it's large and it's close to, to the mouse. So those two things kind of impose hierarchical structure. Hierarchical structure just comes out from those two laws.
Interactive completion pot.
Yeah, but we could try different, like completely different widgets, like different ways to kind of influence the computer to select it more efficiently. Like interactive completion, like you say, context is a very strong indicator of what we might want to do next. So this map could actually take this into account. So if we are using some part of the map a lot, this part of the map could be enlarged and it could be more pronounced, easier to select. These kind of things, like language models are another good example, or just machine learning. Machine learning can just analyze the patterns of usage and suggest likely things that we would do next. So I'm very intrigued by what the next episode is going to suggest. Cool.
You get a garden of stuff. where stuff you use often together grows in small personalized area.
Yeah.
Besides the big mall map.
Yeah, this is a nice idea, by the way. I think this is called, there is a whole idea in application design called moldable. Moldable development, yeah. Well, when you mentioned this garden idea, this kind of came to mind.
I shared it, lol.
Okay, moving on, because our kind of point for today was to... So we've done a little bit, but it would be nice if we actually finish more of those kind of tasks. Okay, let's do the describing. We don't have many instructions left, so let's just do it. Okay, and I see we still have the instruction that increments the shadow stack pointer. I have to fix this. Okay, miscellaneous. Scroll through them. Cool. It's not like we are working a lot now. We're just waiting for the model to write this for us. Okay, those two tasks should be fairly simple. I think we might work on them in parallel, actually. Okay, it finished. I mean, it's getting pretty lazy, the model. And those comments are totally useless. Okay, I will skip RDTSCP because this is more of a specialist, like getting the core ID. It's probably not what most users want when they want to read current time.
Can you make it work for virtual assembly line first, and then scale to x86 and others?
Yeah, I've been thinking about this. LLVM has a pretty decent internal assembly, which is actually graph-based, so it would be even... In some ways, it would be even cleaner to actually show a graph in AUTOMAT of instructions. The reason I'm going with assembly is that those graph-based networks, like data flow networks, they usually produce spaghetti. And this is the common, like most people, when they think of visual programming languages and, complex logic, it always results in just a huge mess of connections going everywhere. It works, but it is a little bit, what was the term? Alien to people. Like when you see something like that, it's just, what the hell does it do? Yes, it...
Want island.
No, I think this sequential flow, when you actually follow just instruction by instruction, like sequential flow of instructions, I think it's easier to just think about this, to look at, hey, I do this, then I do this, I do this. I think it's more intuitive for people. If anybody ever followed a cooking recipe, they know this idea of following instruction after instruction. This is a little bit, I think, more natural than a graph of values which are computed and aggregate until you compute the final leaf value.
Clouds of code. Cool, I agree.
There were some ideas about using virtual instruction sets. There are some nice ones which are actually just translated to x86 assembly, still very efficiently. So it's not a big difference between using a fake one or a real one. But the real one, it also has some nice properties. So if we want to automate games, and this is what we want to do, we will have to mess with memory of programs. We will have to hook stuff. We will have to basically override the memory of other processes. And having some objects that can do that, I think is nice. I think it will make it easier for us to do hooking, for example, of function calls in other processes. So,
You combine. Where do you stop sequential and do visual?
So we'll have something like that. So a bunch of cards, when they are stacked on top of each other, they will all have the same dimensions. So they will be looking more like that. That is the plan for now. Each card is going to have a connector at the bottom. So if you have an external object, you will be able to hook it up, and when the execution reaches the end, the assembly will kind of stop, we will update those register values, and we will jump to the next object, which was connected by this cable.
I see.
And if there is like a conditional jump instruction, then it will have this connector on the side. So those connectors, actually next week we are actually going to write the assembler. That's the plan. So this is when we will actually be taking a look at those connectors and trying to convert a bunch of cards with connectors into like a sequence of instructions in memory. Okay, I got rid of LDTSC.
Have you found a use for short assembly scripts before? It's so unusual to me.
Yeah, so at work we used to do some malware fighting, and there are some situations where assembly is very useful there. I don't want to go into details because a lot of this stuff is... A lot of security relies on obscurity. It doesn't sound great, but this is how it is. So I don't want to kind of divulge too much kind of tricks which are used to catch malware, not to kind of make them too well known. So yeah, in computer security, and I guess that's it. And you know, inline assembly, like some people who want to optimize stuff, they sometimes go the inline assembly route. There is a good, actually, let me find this.
For game 0 done well.
I mean, for games, yeah, for hooking, absolutely, hooking, the way to do it is using assembly quite often. You have to rewrite the initial, like the prologue of the function. There is a good repository, these FFmpeg assembly lessons. I should start this.
I see. Thanks.
Yeah, they are focusing on the vector instructions. We could introduce vector instructions. What is Movio? I guess it's some macro. Anyway. Okay, so RD-seed is for reading true random numbers. So this is going to set and then we have RD-rand.
Rose compiling x86 reference manual to Python botch call.
Yep. So the difference between them seems that this RD-seed, it stresses that it's compliant with some standards. So I think this may be some quick and dirty random, and this may be the like proper high quality hardware random number generator. The descriptions seem very similar in both cases. I think the description should be similar. Should somehow distinguish them. Pseudorandom. Okay, this is actually one of those things that I called alien before. If I told somebody who's totally non-technical what it means to randomize, they would probably know what I mean. But when I told them pseudo-randomize, I could say slow to indicate that it's slow. I don't know. Let's see how this looks. Okay. So we have just two more categories to cover: unsigned math and signed math. Yeah, let's start with shifts. a lot of shifts. So I will help the model and split them. You have shift rights and shift lefts. I have no idea what are those SH. Okay, those are double shifts. We don't want them. And what is SHLX? Okay, so this is without flags. I think we had similar instructions here. I think there were some add instructions that also had this variant, which avoided flags. ADCX, ADOX, those two. Okay, we actually removed this. So I think we may also remove those flag-free instructions as well. no, this is not accumulator shift. So this is shift by 1. Shift right by 1. So this is the first category. Maybe shift is not a good term for this, because this is arithmetic shift. Let's apply. We need to give it a moment to kind of combine the suggestion with our code. And shift is the wrong word. Let's accept. So let's rename it to divide. I think this immediate should probably use 2, if I remember correctly. It will crash if it's wrong. I know it's a little bit alien, but I'm going to add this symbol to distinguish between signed and unsigned multiplication. see how it looks. This plus minus, I'm not sure where to put this. I think this plus minus sign could be stored elsewhere. Maybe we could highlight this word using different color to indicate that it's a signed operation. We don't have to just use text, we can use color as well. And one of the ideas was to actually use color to distinguish signed and unsigned values, because they often share the same memory, they share the same registers, they may even share the same flags. So when some operation assumes that we have a signed value, then maybe we could put this sign here in the name of the operation. Okay. The next category, I guess, is divisions. Okay, divide operation is actually quite specific. If we are dividing R1 by R2, So this is an interesting way to express this operation. And actually each variant works slightly differently. This 8-bit divide is going to be hard to display. I just want to see if this is going to be readable. No, it's not going to be readable at all. Because the idea is that this is a value of the register before the operation and this is the value after the operation.
The average brain says.
Why?
Hey. So now this could be visualized way better.
How are you?
All right, thanks. So instead of equality, let's use left arrow. Or maybe set. Yeah, I think English is even better.
What are you pro-gaming?
This is an environment for automating games. So we have a bunch of components here that can be used to react to events. For instance, this is a hotkey. When I press F3, it activates and sends signals to other objects. And together they can do stuff. Here, for example, I have a timeline which is connected to those key pressers. So when I play it back, it can press keys on my PC. And I could loop it, so it will do this over and over. And right now, I'm trying to add a new type of object that's going to be executing basic math, essentially. Not only basic math, just all sorts of things that your computer can do anyway. Like adding numbers, dividing numbers, checking, like comparing two numbers with another. Like that.
Cool.
Yeah. Right now I'm just trying to translate all of the instructions that the computer can execute, that the processor can execute, into those cards. So this is the divide operation. Is there a symbol for a reminder? Definitely not percent. Modulo, maybe modulo. This just made the description super long. But we will fix this, because I don't support new lines yet. I will. That's the plan. We will have new lines here. So we will try to make it fit on the card. Maybe we should do this straight away. Anyway, I will leave it like it is. So multiply. We have a multiply instruction and a mul xx. Mul x. I have no idea what is mul x. Okay, multiply without affecting flags. That means we are skipping this.
How long have you been coding for?
This thing for about 2 years or less than 2 years, slightly more than a year.
Patrick Nowak says,
Hey, why are you doing such a difficult stuff? You should have put it in ChatGPT. Make me an app. AUTOMAT Live-Coding.
It is helping us a lot, ChatGPT. I mean, we are going to use this actually right now. So here I can put I can tell it to do this, and in like a minute it's going to be implemented.
Jokes aside, are you using ChatGPT?
Yeah, in this case I'm using O3 Mini. This one, it tends to modify my own code a little bit less. So in general, Claude is very good, but I've seen that it tends to kind of touch places which it shouldn't. It's still better than the others, but the bar is very low here, I would say. Is there IMUL X? There is no. Okay, now we can apply this modification that it has done for us. Looks weird. So this is the 16-bit variant. And the 16-bit DX-AX, it actually splits the output into two registers. And then we have 32-bit variant, which uses EDX and EAX. And the 64-bit. So we are first regenerating the x86HH, removing those mul-x opcodes, and the remaining ones should look nicer now. The sizes of those registers, they are important here. We are not showing them yet. Maybe we should. Okay, that was unsigned multiplication. Then we have signed extension. Apparently we already covered this. The chain additions we seem to have covered, and chain subtractions also covered. Okay, I guess this is all of the unsigned math. Next, signed math. Actually, those shifts, I think this is in the wrong category. Yeah. Okay, no, I messed this up now. This should be AL. wonder what's the difference between SAL. Yeah, arithmetic and logical are the same shifts. Much more of them. This X variant, we'll get rid of this. Now we can split them into categories. This is shift by 1. Negations are totally different, separate things. Okay. And negation. this extend we have. And there are 4 instructions for dividing stuff. I guess they have, as usual, totally different registers. Yep. Actually, this unsigned divide, it wasn't really complete because the 16-bit version and larger, they actually behave slightly differently. Okay, we have to break it down. This was a tricky one. Now the 16-bit variant. Set DX and AX. Sorry. Okay, and something very similar we'll have for all of the others. So, 32-bit version uses just extended registers. kind of the signed version is going to be almost the same. I think I should somehow distinguish them. But because they are in different categories, maybe I don't have to. Where do we have those opcodes? Anyway, I will implement those now.
CP Chica says,
Hello.
Hey, I removed I. Okay, that's better. Okay, I see that this is actually very interesting that we have way more signed multiplication instructions than regular multiplication, unsigned ones. This looks like a much more flexible data type. So if you're hesitating between using int versus unsigned, I think actually int is way better if you're multiplying or dividing stuff. Because the compiler has a wide, more instructions to select from. Anyway, let's group them into categories. Is there no 8? Oh, apparently not. Okay, so this is the single register version. This is the hard one, so let's do this first. Okay, and it works differently for each size of the data type. So this is AX. We will first do the large ones. Okay, perfect. Okay, next we have a version with 2 registers. I think this will work. I think LLVM duplicates the target register here, so even though it says error, it probably has free operands. See. Nice. I will just scroll through all of the instructions that we have. Okay, we did have this CBW. I think we scrolled through everything. What category is this in? Signed divide. Yeah, it's here. I don't think it should be here. We need a new group for those. Oh no, I remember. I know why they were there. Yeah, I will undo this change. It's there because those instructions, they help you prepare the EDX register for division. Those are the last instructions that we need. and each of them is slightly different, so we just need to include each of them separately. CDQ. And the last one. They will look identical right now because we don't show the number of bits in a register at all. But we are going to fix this next. Yeah, so we have some operations for extending signs. There is a different way of setting that, I could say, a more kind of active. Yeah. It allows us to take a byte, expand it into double byte, into a word into a double word into a quad word, and then we can even duplicate the sign into RDX. I think those, I'm not sure if they are really related to the division. Anyway. Okay, so we finished this. So this is 40% of what we planned for today. I guess we can do more. I will need more tea. We can do this machine code printing, definitely. And maybe also register size. Maybe it would be nice if we could break long lines, break long. That would be nice. But let's start with machine code. Here we have those contents. I don't think this is super important. The machine code is on the bottom, so okay. It's going to be similar, actually much easier. So we have to get the assembler. We go into code emitter. We do encode instruction. Here we need a small vector. I mean, really, we are not going to have more than one fix-up, so just one. And subtarget info, this is part of MCS. Maybe we need a pointer here. Okay, now we have the machine code inside the buffer. We should convert it into hex. We have a header for this specific stuff. Let's do this bytes to hex. Okay, so this is our machine code. We can measure the width. Nice. Actually, I'm not sure. Let's just try to draw this. And see where we end up. It's not bad. I think it should be lower, so should probably subtract that. Cool. Okay, so we have a section in the corner of the card with machine code. So you can see which instructions are long and which are short. This is super long, it takes 4 bytes, this huge immediate value. It's a good argument to use shorter instructions. For example, in the signed division, those operations that extend the sign of registers. Some of them are single byte. Okay, so we have machine code in the corner. That is done. Next, I think we could print the register size. So my idea for register size is as follows. Within the MC_inst. So we have a table because we are linking with LLVM that tells us the parameters of every instruction, and we can query how large is some operand. So I think we could use that to put a number here. Not super confident, but I think we could try this. I think there are some operations which store data at a specific bits of some register. I think then we would have to somehow indicate this. I'm thinking that on top of the icon we could put the range of bits that is being stored. For example, bits 15 to 8. It sometimes happens. And on the bottom, we would say the number of bits that are part of this register. So let's put the width of the register. Contents. Now we are interested in contents. And there we go, register operand. Okay, there is this operands. What is the type of this? This array ref, so we can use index. So we have this class info. Now I want to translate this to number. Reg size in bits. Yeah, perfect. I'm just drawing whatever. I just want to see some text. I hope it's going to be right. Okay, so we have some numbers. They just should be a little bit smaller and in the right place. I actually don't want to use heavy font here. Or maybe I won't. But it should be way smaller. So we have a register and we have its size. This is way too large though. I think ideally we should use the same font that we are using for text. fine font. I think it is a little bit too small. It doesn't seem like it's part of the text, so it has to be heavy font, but it has to be very small. Let's create a new font type. Okay, we want semi-bold, that's fine, but it will be just tiny. Looks good. Maybe it should be slightly higher. Divided by 2, let's see. Yeah, I think this is good. Oh, now we can see differences between those cards. This is an 8. Bit version, 16, 32 and 64. I think we should also add those subscripts to fixed registers, which don't have those values, and to immediates. This is a very weird instruction. Set di to sign extended this. It just extracts part of the larger register, so it's not really sign extension. or this. I think this is done, but I will leave a to-do to show. Print fixed register size. And it is getting kind of late. So I think I will cut this for today. I will try to do this breaking of lines tomorrow offline. And maybe on Friday, I think we will do the key feature, which is the ability to pull instructions out of the library. And do drag and drop connections so that they can kind of snap to each other. Still not looking, amazing, because a lot of the instruction cards are tiny or they extend behind the lines, but it's going to look much better once we do the line breaks. Some of the cards are going to be fairly complex. I mean, this one we didn't even try to make this simple, because the plan with bits is to actually use a different visual representation here, so no worries. This is just a temporary. Okay, see you on Friday. Bye.